got ax plus by equals c, a straight line. A, B, and C are real non-zero constants, and we're looking for a necessary but not sufficient condition for the line to have a positive gradient and a positive y-intercept. So what that means is if it's not sufficient, then that means that it's not implying it that way. But if it's necessary, then positive gradient and positive y-intercept would imply this. So let's work our way through it. I think that's maybe the best thing. Actually, before we do that, let's try and write it in the form y equals mx plus c. So ax plus by equals c, which means by is equal to minus ax plus c, which means y is equal to minus a over bx plus c over b. Okay. Now, if c over b was positive and a over b was negative, that would guarantee a positive gradient and a positive y-intercept. So this would imply, left would imply the right. So actually we can see that's not it because we're not looking for a sufficient condition. We're looking for it to not be sufficient. If c over b was negative, actually we'd get a negative y-intercept. That wouldn't imply it either way as well. And oh, but would a positive y-intercept imply c over b was negative? No, it wouldn't. So this one's out. A being bigger than b or a being less than b doesn't really come into it because it's all about really the signs in this case. And it's this next one we need to really think about. So if we have a positive gradient and a positive y-intercept, then whatever b is, we need minus a and c. We need them to have the same sign. So if b was positive, we would need c to be positive, and we would need minus a to be positive. So a would have to be negative. So if b is positive, c is positive, a is negative. If b is negative, c would be negative and a would be positive. So that will imply that a and c have opposite signs, and that's our answer E. Whereas if A and C had opposite signs, it doesn't guarantee that we have a positive gradient because again, it depends on B. So let's say A was equal to, I don't know, 3 and C was equal to minus 5. Then, because I've got a minus here, let's say B was then equal to 2. Then actually we'd be getting a negative gradient and a negative y-intercept. So them having opposite signs does not imply it. Whereas if C was minus 2, sorry, if B was minus 2, then we would. But definitely the left-hand side is not implying the right-hand side, but the right-hand side is implying the left-hand side. It's a bit subtle, but I'm hoping this is making sense. Our answer is E.